Hello and welcome back to the Topo Maps lab for physical geology. And I want to try to finish this up today in this video. The next part deals with relief and gradient. So the relief is basically the difference in elevation between 2 points or 2 elevation points. And you can read a little bit more about it, but it's just different elevation of 2 points. Gradient is, you've probably heard of the rise over the run, right? The rise over the run, and in geology, or at least in topographic maps, the way we look at it, or especially when we start doing rivers, because we want to know what the gradient of a river or stream is going to be, and we look at the elevation change over the distance. It's always going to be in feet per mile. So that's one unit that kind of has kept English unit that's been kept in geology is a feet per mile. I guess you could do meters per kilometer, but for some reason the feet per mile has remained, right? And you'll see that most of the topo maps that we have in the US, the elevations are going to be in feet. For example, on the map we're looking at here, the NS quadrangle, they'll tell you that the contour interval here is 40 feet, right? So already the elevations are in feet. So because these topo maps already have this in feet, we go ahead and use the feet per mile. And remember, what's unique about this map, the 1 to 62,500, which is basically the 15-minute quadrangle that we've been looking at, is that each little box is about a mile, right? So that's 1 mile in distance there. So that kind of makes it a little bit easier there as well. Let's see, what are we looking at here? I guess we're looking at this little benchmark on the little example I have on the next page here. And so one of the things we do, to just kind of review a little bit about contour lines and different features. I'll just kind of go over a few points here. So remember, a contour line, for example, this 100-foot contour line that you see coming around here, every point on that line is 100 feet. 100 feet above sea level. So over here they have sea level at 0, right? So sea level at 0. And then as you go up, and in this case the contour interval is 20 feet. So if that would be 0, and that would be 20 feet, then you go up to 40 feet, 60 feet, 80 feet, 100 feet. And so if we go from 100 up here to the 200-foot contour, which is this little hole we have up here, you see that we go from the 100, we go 120, 140, 160, 180, 200, right? So that's that 20-foot contour interval. So that's one thing that you may be asked to determine, like what would be the elevation of a point right here? Well, if a point is right there, it would be at 120, 140, 160, right? Or if it's somewhere in the middle, you make a guess. It would be maybe, if that's 160 and that's 180, then maybe it's 170, right? You make an educated estimate there. Another feature of contour lines is this idea of a depression. So here, a closed depression, you'll see these contour lines that have hatcher marks on them. These little tick marks on them are called hatchers. And so when you see the hatcher lines, that indicates that there's a hole there, or a depression, right? But also note, as you're going up the hill, I'm climbing elevation. I got 120, 140, 160, 180, 200. Then remember, I might go up to 205, 210. I might not enough to get up to 220. Otherwise, I'd see the next contour. But I get a little bit more than 200. But then I start going into the hole, into the depression. So I have to hit that 200. So by rule, the first depression contour, the first hatchered contour with little hatcher marks there, is always going to be the same elevation as a preceding lower elevation contour. And I think I have an example of that in the lab in here. So here's a good example. As you're going up the hill, in this case, you're going 280. These are 10-foot contour intervals, right? 280, 290, 300. You see I go a little higher than 300, not as high as 310, but then I start going into the hole. And so the first elevation contour you see is going to be the same as the preceding lower elevation contour, right? So that's kind of the idea of how these hatchers work. So in this case, I see 300, but then you can see 300 repeats, right? Because I go up a little higher than 300, and then I go into that hole, right? So that's kind of the idea about this. And the reason I mention that is because we have a problem here that we'll deal with later on. And then I think there's another problem that we'll deal, over here on this page here, we'll deal with some contours and some hatchered lines there as well. Other things to look at on these topo maps are the benchmarks. So wherever you see this BM, stands for benchmark. So the elevation of that point has been surveyed. In this case, it's 24 feet. Sometimes it doesn't say benchmarks, but here they got an elevation of 266 feet at that X there. And see if there's another benchmark anywhere in here. And then another thing to note is depending on how close the contour lines are. So if the contour lines are really closely spaced, that means it's steep, right? You're gaining elevation or losing elevation rapidly over a shorter distance. If the contour lines are widely spaced, that means it's a gentler slope and you're changing elevation not as dramatically as a steep slope here. Another thing that's really important in topographic maps is this thing called the rule of V. And the rule of V states that when a contour line crosses a stream valley, here's a little stream, note that it makes a characteristic V. And that closed end of the V here points uphill. It always points up slope. So here's a nice little V right there. Some maps do not give you the elevations. So they might give you the interval, but they don't give you the elevation. So your job is to figure out which way is up and which way is down, right? And so one way to do that is by using the rule of V. And then when we draw contoured maps, because we'll be making one of these later today, we have to emphasize that V pattern in the stream valleys here. So again, the rule of V. In the lab, I do have this section called Rules for Contour Lines, and you can see this rule of V down here is explained here at number 13. Really important. Out of all of these, it's probably the most important one. The other ones I've kind of covered already. In fact, we'll do some examples of drawing contours and stuff like this for like this number 1 here. Really important, rule of V, right? So now as we look at some of the problems here, remember we're not doing the Bray quadrangle, we're doing over here the Ennis quadrangle down here. So we're going to look at the lower right margin of the map, find the small locator map of the state of Montana. The black rectangle shows the location depicted by this map. And what part of the state is the Ennis quadrangle located? So here is the map, and there's a locator map right there. You can see it's kind of in the southwestern part of Montana. So on the lab, you would say southwestern part of Montana, right? So that just gives you an idea of where this part of Montana, this Ennis quadrangle, occurs within the state. So every USGS topo map should have one of these locator maps, right? All right, so you can answer that question for number 1. Let's look at the next one here. So I'll check that one off. And then on the next page, so the map is covered with those grid lines. Remember, those are the section lines. It's like I can see section 29, section 32 there, section 5, right? Those are part of the township and ranges that we talked about already. And each is about a square mile, right? So we talked about how each of these is a square mile, one section. Each section has a red number at its center. The grid is part of the Public Land Survey, PLS. The numbers repeat, so there are 2 numbered ones, actually there's going to be several on this map here, right? Because there's different townships and ranges, right? What is the number of the red square that contains racetrack located near the center of the map south of Ennis Lake, right? So if we go over here, there's a racetrack right there. Yeah, there's a racetrack, so it's section 19, right? So you would say section 19 for, and usually we put it as SEC 19, right, for section 19. And what is a red number in the red square that contains a Lawton Ranch in the south part of the map? So again, your job would be to go to the map here and find Lawton Ranch and label that. I'm not going to do it for you, so I'll let you do this one on your own. And then what is the name of the mountain? So again, now I'm getting a little bit more detail. So I want you to look at Township 6 South, Range 2 East, and it's section 19. So basically for that, you would go to the side of the map. You want Township 4 South. So 4 South is here. So it's going to be somewhere up in here, but then you want to find Range 2 East, right? So it's going to be somewhere in here, right? And you want to find that location, right? So that would be, I'll let you do this one here. And same thing with this one. I'll let you do that one there for the break, for the Ennis quadrangle. And let's look at number 6. What is the name of the national forest found in the center? Okay, you can do that one on your own. I'll let you do that one. What is the name of the ranger station? Same idea. I'll let you find that one. Now we're going to do a little bit of a gradient problem here. Here we're looking for benchmark 680 in the northwest corner of section 22, Township 6 South, Range 1 East, right? So let's find that. So section 22, Township 6 South, Range 1 East. So right away I know that Township 6 South is going to be way down here. There's 5 South, Township 6 South, and I want Range 1 East. Yeah, Range 1 East. So there's Range 2 East, there's Range 1 East right here. So, and I know that Township 6 South, and I want section 22, which is going to be, yeah, that's 21, this is 22 right here, right? And it says, what is the gradient between benchmark 6, oh, there's benchmark 6080 right there. See, 60, so you want that benchmark there. So we found this benchmark. Now we want benchmark 499 in section 2, Township 6 South, Range 1 West. So that's going to be over here. So it's going to be section 2, and it's 4966. So we're going this way, Township 6 South, and we want Range 1 West. And it's, oh, there it is, 4966. That's it right there. So basically, we want that point there, and actually let me zoom out a little bit. So we want that point there, and then the other elevation we had, 6080, which was in section 22, right there. There's 6080. So basically that's 6080 there, and then that. So we want this distance here, right? You know, since we don't have the map as a paper copy, we can sort of estimate it. Let's count the number of boxes. You know, we'll make an educated guess, right? So if we go from the middle of this box to about here, that's about 1 mile. Remember these boxes are 1 mile. So there's probably 1 mile there, 2 miles, 3 miles, and I'm going to 4. So about 4.5 miles. So the distance between this point here, this elevation in section 2, and this elevation in section 22 is about 4.5 miles. We're just going to make an educated guess there. Another way we can do it is we can look at the distance here. You can see that's about 4 miles. You can see it covers about that much, maybe a little bit more. So let's call it 4.5 miles, right? So now let's look at the map here. So the gradient is going to be the difference in elevation between 6080 minus 4966 divided by the 4.5 miles, right? So remember, this is going to be in feet up here, right? That's going to be in feet. And so your answer is going to be in feet per mile. So go ahead and do the math there, and then you can figure out the gradient, right? So that's one way that you can do it. Obviously, all right, so that's a little bit on that part there. And so I'm going to make sure you come back and answer these questions up in here. Now the next section deals with contour lines. And then these, you know, they're brown. In fact, we'll zoom in there a little bit more so you can see them more clearly. So these brown contour lines, right? And you can see the little rule of V's. See when it crosses the stream valley there? See the rule of V? So that's another important feature we see. This map is a little bit different than other maps in that it's called a shaded relief map because you see these kind of shaded patterns here. But again, you can still see the contour lines. And then we see that it's a 40-foot contour interval here. So let's look at some of the questions here. As you look around the map, are the brown contour lines roughly parallel to one another? Yeah, so you can answer that. So they look roughly parallel there. So why don't you answer that question there? Do the brown lines tend to cross? Oh, well, actually, that's one of the rules for contour lines. Contour lines should never cross because you can't have one point at two different elevations, right? So each point has to be, so contour lines can merge like at a cliff, but they should never cross, right? And so, so you probably want to say no for that one. For number 3, do any of the brown contour lines run off the edge of the map? Yeah, you can sort of see them running off here at the map. So they'll extend onto the next map. In this case, it's a Cameron map on the next map to the south here. So we're not doing brace. So here, we're doing number 5. On the Ennis quadrangle, do the contour lines on Red Knob, and in fact, I know where Red Knob is. Let's go find Red Knob. It's up here by Ennis Lake. So there's Red Knob right there in section 27. So the question is, do the contour lines go around and form loops back on themselves, right? So you can, so take a look at that and you can answer that question there for Red Knob. And then now if we look at what we just did here, questions on what you just experienced. Let's see. Yeah, so you can answer these. So I think you can do all these on your own. So I'll let you do basically all these. Remember, we're just not doing the Bray quadrangle here, but you should be able to answer all these questions here on your own. So I'll leave you to that one. So this next part here deals with reading topographic maps. One of the more important things is the scale, and you'll see that maps have basically 3 different ways of showing you scale. At least these topographic maps do. So if we go down to the bottom, you see that one scale is called the fractional scale, and that's also called the representative fractional scale. And basically it's how much we've shrunk down this part of the earth to fit on the piece of paper. So we shrunk it down 62,500 times to fit on this 15-minute quadrangle, right? So every inch or centimeter you measure on this map is equivalent to that same number of units on the ground. For example, if I measure 1 centimeter on this map, I'm really measuring 62,500 centimeters in the real world out on the ground. Usually we do inches. So if I measure 1 inch, like the distance between in one section, that's 1 inch, right, which is about a mile on this map, it covers 62,500 inches, right? So 1 inch on the map is 62,500 inches. So that's kind of this whole thing about the distance on the map and distance on the ground, right? So you measure 1 unit on the map, you have equivalent units on the ground, right? In this case, 62,500. That's what it's telling you. Obviously, it's kind of hard to deal with 62,500 inches, so you'd have to divide by 12 to give you feet and divide by 5280 to give you miles. I don't know if I do that over here. Talk about it there. So make sure you read here, right? So the 52, somewhere in here I have the 5280, so that's kind of a magic number you should know. There it is, 5280 feet on the ground, right? So basically that's a Bray quadrangle. 1 inch, that's on the 6500, but let me give you the rule is that 1 mile, this is what I want you to know, is 5,280 feet. And obviously 1 foot is 12 inches, right? We all know that, right? And so now we can go from inches to feet and feet to mile. Really, that's what we're getting to. And I'm sure somewhere I have that written in here. So when you read through this, you can sort of figure it out. And then what we're doing here is so read what I'm doing talking about here about Jumping Horse Stock Ranch, and you can find those places now. And now you know how to navigate through the map here. Remember, we're not doing the Bray quadrangle, but for the Ennis quadrangle, take a look here for number 2 here on this Ennis quadrangle. Yeah, so go find Cowboy Heaven, calculate the number of feet and then miles between the 2 points. So between Cowboy Heaven and Lake Camp. So I know Cowboy Heaven is way up here on the top of the map here, but I saw it up here. Cowboy Heaven is there is Cowboy Heaven, section 22. And then they want between Cowboy Heaven and Meadow Lake Camp, which is right there. So there's Cowboy Heaven. So Meadow Lake Camp is right here in section 34, Cowboy Heavens. So that distance, what the lab is saying, that distance is 6.5 inches apart, right? So basically what you need to do is you want to figure out the number of feet then miles, right? Remember on this map, on the NS quadrangle is 1 inch is 62,500 inches, right? So, which basically, if you divide that by 12, right? So let's do that real quick. So 62,500 divided by 12, 5,208 feet, right? So basically, 1 inch is 5,208 feet. And I think I do that up here somewhere. Yeah, it's up. I do it up. Yeah, so 1 inch is 52, and as you can see, I do it up here as well, right? So now, if you measured 6.5 inches, just take that times that will give you the feet, and then you divide it by the 5,280 to give you the miles, right? So you should be able to do that one. I'm not going to do any more on that for you. The other type of scale is some maps give you a verbal scale. In this case, 1 inch is 5,208, or 1 inch is 10 miles, or 1 inch is 100 miles, right? On the NS quadrangle, what is the distance of feet between the Lawton Ranch to Jumping Horse Ranch, right? So you can see I've sort of done it up here already. So now you just kind of convert those. And then remember, we're not doing the Bray quadrangle, so don't do this last part here. But certainly do this part over here. So I'll let you do the scale there. The next part here deals with landforms. So read about the landforms, and again, we're doing contour interval, and what are we asking about the NS quadrangle? So find Lawton Ranch. Note that the only bold contour line are labeled with elevations. Yeah. So let's find, that's one thing I didn't mention earlier. So Lawton Ranch. So we found Lawton Ranch. Note that only the bold contour lines are labeled with elevation. And you can sort of see, yeah, so that says 5,800, it looks like. Yeah, 5,800. No, that's 6,000. So near Lawton Ranch, this contour line is 6,000, 5,800, 5,600, right? And remember, it's every 40 feet. So if this is 5,800, so the index contours are the ones that are labeled. These other contours are not. But remember, it's 40 feet interval. So if that's 58, that's 5840, 5880, 5920, 5960, 6,000, right? So we get to the 6,000 feet. So we're seeing that we got these, yeah, Lawton Ranch is close to 6,000 feet elevation. Note that the elevation decreases to the west, yep. You will see the, yeah, so I just did those here. So the bold contours are called the index contours. You are standing on the 56-foot contour. Count how many lines you will, yeah, so we'll count how many lines we'll get in order to get up to the 58 contour, right? Make sure you count the, yeah. So if we stand here at 56, there's 1, 2, 3, 4, 5 to get up to 58. So we had 5 contours covering 200 feet, right? So you would put 5 contours here. And divide by 200, and so basically we get the 40 feet, right? That's all it's asking to do there. I talked about benchmarks, so remember, we're not doing Bray, so go ahead and do this one for NS quadrangle there. And then I want you to read through this contours and patterns of contour lines, and this is kind of where I talk more about the rule of E. We're not doing Bray quadrangle, but make sure you come and do this NS quadrangle problems here. And then I even kind of have a little place where you know, another zoom of the map where I want you to look. And I think I even bolded some contour lines for you to look there. So you should be able to get through all these. Remember, only do the NS quadrangle questions here, right? Don't worry about the Bray quadrangle ones. So you should be able to work through that one there. I talked about depression contours. And this is kind of... for this lab, I'm really going to look at this closely, this problem here, because you're going to work on this topographic map on the next page. So we're going to write the correct elevations, right? So that's basically, it's talking about this map on this next page right here. And one thing, they do give us one contour line, and they do give us a contour interval. So study, and there's a stream right here. This is a little stream. And note that the V's, right, the closed end of the V's, use the rule of V's to figure out which way the stream is flowing. Is the stream flowing kind of toward the north, or is it flowing toward the south? But remember your rule of V's. The instructions for finish that is follow these instructions here and make sure you write them on this map here. I will be checking this map. I'll be grading this carefully. So this is kind of like the end product for this lab here. finishing this little topographic map here. And then we even have some depression contours here as well. So you'll do that, and then I talked about the rules for contouring. And then this next part here is, in fact, one of the things that's covered, that might help you work this problem out is this rule 1 of how to navigate for drawing these contour lines. But let's do a couple here. So they've already done one for you, and we want to do contour lines using 100-foot contour interval, right? So they've already drawn the 100 foot, and see how they kind of emphasize the rule of V's there? So we're going to do the 200 feet, right? So I see 200 there, so we're going to start here. We're going to go around here, 200, 200. We're going to do a little rule of V, and then come down here. You can see the little rule of V I made there. And then this is probably 200 all through here, and these are probably 200 as well. So I'll make a little rule of V there. And then I'm off the page. So that's a 200-foot contour, right? So I'm just kind of guessing that these are 200, because that's 300 and that's 100, so that's probably 200 right there, right? So then for the 300-foot contour, if that's 250 and that's 350, then this must be 300. I'm going to loop around here. I'm going to do a little rule of V here. If that's 300, that's probably 300 right there as well. Go through that 300. Hit this 300, do another rule of V, and then going off this way, and I'm probably looks like it's kind of looping off the page here a little bit, something like that. And so keep working your way up. One of the things you'll find is, in fact, let's look at the 500-foot contour. So it looks like the 500-foot contour does a rule of V right there, and then that's probably 500 right there. There's a 500 there. 600 probably does a little rule of V there to that 500. That's probably 500 there. Then it's going to loop off the page there, but then you can see it's coming back over here, right? And it's probably going to join up with this 500 somewhere over here. So it looks like there's a mountaintop up here. In fact, let's just do the 600. So 600 is probably this one there, that one. Yeah, so there's a little mountaintop right there, and then the benchmark at 675. So once you finish off I guess you're only doing the 400 in here, right? And then for this one, and this is another one, you want to do every 10 feet up here, every 10 feet contour interval. So obviously sea level is going to be 0. Then it's 10, 20, 30, 40. So this is going to be 30 and this is 40. So remember the rules for hatchers, right? And then work your way up over here, and also don't forget about to write these elevations over here. So I'll let you work on that one. And finally, the last part deals with these profiles, and we have this line of section where we want to show the profile is basically like the skyline view of what the topography looks like. So you can see here we have a map, and what we're going to do here is wherever, in fact, probably the first thing to do is figure out our elevation. So the highest point we have here is about 800. That's a 700-foot contour. So we're not going to go much higher than 800 feet along this line of section, A to A prime. And we have a 20-foot contour interval. So the lowest elevation we get here, if that's 800, 780, 760, and that's 760 there. And then looks like we go down to 700, and we go, yeah. So it looks like the lowest elevation we go is 700. So to make this easy, let's just say that down at the bottom here, this is 600 feet. This is 700 feet over here, and this is 800 feet. So this is gonna be our profile, our vertical scale. So it's like if we were standing here, we'd be looking up the hill, and we'd see a hill there, a little stream, another little hill, another stream, and then another hill over here. So we're gonna show that on this little grid paper here, right? So ideally you want to use a ruler for this, some sort of straight edge. And so the first thing you want to do is wherever a contour line crosses this line of section, you place that elevation down here on the vertical scale. So if that's 780, this is if that's 800, that's 780, 760, this is 740 right there. So, and remember, since there are 10 boxes here, so each box is 10 feet over here. So 740, I come down here, so that's 700, 10, 20, 30, 40. I put a tick mark right there. And then I go over here, and then that's the next elevation. It's 20 feet higher. So if that's 740, that's 760. So I go straight down. So that's 40, 50, 60. Put a tick mark there. Then as I go, that's 780. Go up to 780, put a tick mark right there. So see how I'm doing this? Then I don't get to 800 because my line of section doesn't touch it, but I get to 780 again over here, right? So I go put a tick mark right there. Then I'm back at 760, and I keep going, and I don't get any lower, but I do find the stream. So I'm going to put a line here, and I put S for stream. Then as I keep going, now I hit this elevation here, and you can see that's 760 again, right? So 780, 760, because it comes around. So let's bring that 760 down here. That's 10, 20, 30, 40, 50, 60. So put a tick mark right there. All right, so I've done part of it, and I'll show you what to do next. I'll let you finish off the rest as you go toward the end of the map here. But once you draw all your tick marks in, you want to smoothly connect these dots. And remember, there's a hilltop here. I can see the hilltop, but I don't get quite as high as 800, so I just go a little bit below it. So you see I'm below 800 right there. Then I'm going to come in here. And then remember, I don't get to 740 here, so that's 740. So this little stream is going to make a little V right there. Then back to 760, right? So I show a little stream right there. But note that I don't go, so that's 10, 20, 30. Well, I'm almost at the 740, right? So you want to be a little bit above 740 because I really don't get down to 740 there. And then you'll see that yeah, so there's a little, in fact, let's just do the next one here. So there's another 760 here. So we did this, so that's 760, we did that one. Here's another 760 right there. So what's happening here is that there's a little ridge right here. Then this starts dropping back down. And then once you do these lower elevations back to a stream again, you'll see this is going to go down. And then you'll go up this hill over here, right? So I'll let you finish that up. And ideally what you want to do with these, after you've completed your profile, shade in the earth, the land, right? So you want to show that this is where the land is, the earth. And then above it is going to just be the air, so to speak, right? So, and then there's some instructions how to do this as well, but I showed you kind of an easier way to do this. But that's about it. Hopefully that will help you complete this lab, and we'll see you next time.